Hey guys, it's Joe again, and I'm going to talk about the same thing we just talked about, which was dealing with currents. We'll be using the same exact circuit here. This time we're going to be doing it a little bit differently using a source transform. Now, I'll go ahead and explain what a source transform is. Now, in this case, we have a circuit that looks like this. And we have a section of the circuit that basically is a 2 ohm resistor and a 9 amp source, and then we have another part of the circuit that is a current of I over 4 and a resistance of 8 ohms. Now we can solve this problem using a source transform method, and the way you do this, I'm not going to talk about this circuit now, but I'll show you in general. If you have a voltage source that is in series with some sort of resistance, so we'll call that V and R. You can, and let's just say there's R2, we'll just call that R1 and R3. You can actually turn this part into, this section of it, into something that looks more like this purple underlined 9 amp 2 ohm source. Now that being said, if we have a voltage like that, and we'll just call it V and R1, we can represent it as something that looks like a current source, and we have to use Ohm's law, so V equals IR. Well, that means that current is equal to voltage over resistance, and we know R1 is R1. So we go V over R1 would be the current here, and that would be in parallel with an R1. And then that would actually be in parallel with R2 and with R3 as well. And that's how that would look. Now let's cut out all this extra stuff. I'm just going to talk about what the source transform will look like in general, in generic terms. So basically, if we had something that was just a voltage source and a series resistance R1 and a V, we'll just say that's grounded, it will look something like that. Now, if we have something that is a current source, we'll just call IX, and it's going up and it's in parallel with a resistor, you can then model it like a voltage source, voltage in series with a resistor. Now, it's very important to note that if you're going to transform a current source, it has to be in parallel with the resistor. If you are going to transform a voltage source, it has to be in series with the resistor. Now the latter, which is this part, looks awfully familiar to this, and it looks really familiar to that. So let's go ahead and reevaluate the circuit to make it look like we just did a transform to it. Okay, so if we want it to look like that, we have two sections. We have this section and we have that section. We'll call it A and section B. So for section A, which we can maybe do a little dotted line around here, we'll have a voltage source, and the voltage, like I said, is current times your resistance, and our current is 9 amps and our resistance is 2 ohms. So we'd be getting an 18 volt source here, and that will be in series with R1, which in this case would be our 2 ohms. So we'd have a 2 ohm resistor here. Okay, now we have section B, and let's just do that in purple. We have section B here. Okay, so in section B, which can start here, we have an I0 over 4 current, and we have a voltage that is 8 ohms. So a current times a resistance, 8 times I0 over 4 is 2I0, so we'd be getting some sort of voltage source here called 2I0, and that would have to be in series with an 8 ohm resistor, and these can connect at any point. So now we have a circuit that looks basically like a straight KVL problem. If we look at the whole problem here, we have something very, very simple that we can solve really quickly. Alright, so by solving this, we got using KVL, we'll have minus 18 volts, and then we'll have plus 2, we'll just call this current I, IO. Now I just want you to know that this current will be we're trying to find the current in this branch here. That's what I'm showing you guys. How do we find the current in this branch? And the way we do it is like this. So basically, everything to the left of here, we're treating as a source. And everything to the right, we're basically treating like we want to find that current. And like I said, if we want to find the current, we'll usually use KVL. So if we have minus 18 plus 2IO plus 8IO, which is 10IO, and then we have plus 2IO. So basically we have 18 is equal to 12IO, and IO is equal to 18 over 12, which is equal to 3/2 of an amp. Okay, and like I said, that is this current. Now we know that the current going through the last branch is 3/2 of an amp. We can go back and say to the regular circuit, and we'll know that, okay, well, we know that there's a voltage here, and we know there's a voltage here, and a voltage here, and all those voltages are the same. Let's call that voltage VA. So VA minus 0, because you're going from VA, and the potential difference is, if that's ground, is 0, over 8 ohms is equal to IO, which we said was 3/2. So basically VA is equal to 8 times 3/2. The 2 will cancel with that, and that will become a 4. So you got 3 times 4, so VA is equal to 12 volts. And that's exactly what we got in the first time. So now we want to find IO. Okay, well basically 12 volts minus 0, because it's VA minus 0, and we're going to divide that by 2, should be equal to IO. Alright, so 12 divided by 2 is 6, so 6 amps is what IO equals. And that's exactly what we got on the last problem. Now I'll show you guys some more source transformations later as we progress. This is just one method of solving this problem here. There's a lot more problems that might be a little more difficult, or for example you might have a circuit that looks like maybe you have some sort of dependent source here, and then maybe like a resistor here, and then maybe this is tied into like some sort of resistance here, and then another part of a circuit here, resistance, and maybe some sort of source. So if you have something like this, it'd be easier to take this resistance with this sort of current here, we'll just call it IX, and maybe we can just transform this to a resistor with some sort of voltage of R1IX, and this is R1, and then we'll have that, and maybe plus minus, and some sort of R2 resistor. Anyway, so on and so forth, and you'll know that this is in parallel, and then you have like another source here, which we can deal with. Well, anyways, guys, I want to thank you for watching my video. Please leave comments. If you have any questions, please feel free to ask them in the comment section. And like I said before, collaboration is key. So if you guys collaborate with each other, you may learn more. Thanks again, and have a great day.